Monitoring and troubleshooting. Let's start off with this monitoring and troubleshooting session where we'll understand the difference between alerts and events, what are different monitoring and alerts capabilities which are built into VeloCloud by VMware SD-WAN. We will also go through the troubleshooting tools which are available on the orchestrator. So here is the agenda. So we'll go over with alerts and events. We'll talk about heartbeats, what's the architecture of the heartbeats. We'll go over the built-in troubleshooting tools which are available today on the orchestrator, the management plane. There is zero CLI involved for the troubleshooting. All the troubleshooting is done from the orchestrator. And then we'll go over some of the troubleshooting scenarios too. So let's get started with the monitoring. There are different types of monitoring. One is the alerts. There are different type of events which occur: API monitoring, SNMP, NetFlow, syslog. So let's start off with alerts. How do basically alert works? What are the impact? We'll talk about different scenarios. What are the frequency of these alerts? How to configure them? Those are the things which we are going to cover in this section. So there are six type of alerts which are defined in the system: edge up and down alert, link up and down alert, VPN tunnel down alert, and HHA failover. Edge here means the CPE device which is installed and configured on the customer premise. So this edge could be on the branch site, or it could be on the data center side where the edge is enabled as a hub device. Take a deep dive into type of alerts and go into the details of those alerts. Let's first talk about the architecture here. Let me quickly go over three key components of the VeloCloud by VMware SD-WAN: the edge device, the CPE device which is on to the branch side, the same device when it is on the data center configured as a hub is the same edge device. The second component is the gateways which are in the cloud. There could be a second model where those gateways are on premise, customer premise. The third piece is the management plane, which is the orchestrator which does all the monitoring, management, troubleshooting functionality. So those three key components. The focus for this session is on the monitoring and the troubleshooting aspect of the edge device. So let's understand the heartbeat architecture, because all the alerts which are generated are based on this heartbeat architecture. So heartbeats are typically sent from the edge device to the orchestrator, to the management plane, and the frequency of these heartbeats are every 30 seconds. These heartbeats are sent from the edge device to the gateway in the overlay. Remember the concept: on every WAN circuits, whether it's public or private, we create an overlay, a VPN tunnel from the edge device to the gateway, or from the edge device to the hub device, or from the edge device to another edge site. So all the SD-WAN functionality works onto those overlay. We are constantly monitoring the overlay network. So the heartbeats are sent over the overlay HTTPS connection from the edge device to the gateway, and then from the gateway to the orchestrator they are sent in HTTPS. There is no overlay from the gateway to the orchestrator. Again, the overlay is built from the edge device to the gateway. From the gateway, the heartbeat are sent over HTTPS. In this heartbeat there are information basically related to the link stats, logs, and other things which orchestrator needs help to find out what exactly the issues are. These heartbeats are basically probes which are sent at a regular interval, in this case every 30 seconds. These are sent from an edge device to the orchestrator through gateways. Now, there might be a situation where the gateway goes down, then these heartbeats are sent directly from the edge device to the orchestrator using HTTPS. These heartbeats are originated from the edge device. And with the help of these heartbeats, the orchestrator knows what's the status or what's the state of the edge devices. Alerts, which are the edge alerts. Remember, the edge is the CPE device, which could be physical or virtual, on the branch site or on the data center site where the edge device is configured or enabled as a hub. So there are two type of alerts here: edge down and edge up alert. These are management driven alerts, and these are triggered when the edge is not able to communicate with the orchestrator. So remember, the heartbeats are sent every 30 seconds. So with four consecutive heartbeats, if they are missed, then that orchestrator declares that edge device as a down, and that is when the edge down alert is triggered. So missing four heartbeats is when the orchestrator will declare that edge as down. Each heartbeat is 30 seconds. This is just a sample screenshot where we are showing you what all information is captured when the edge down or up alert is triggered. So this is for the edge down alert, where it shows for which customer it is, when it was triggered, what are the link information, and then the orchestrator link. So an enterprise admin could click on this link when they receive these alerts in their email. Similarly, there is a edge up alert. These are management plane driven alerts. Heartbeats are sent from the edge device to the orchestrator through the gateway. Now, there might be a case when the edge is up and have successfully established a VPN overlay with other sites, but there might be some communication issue from the edge reaching the orchestrator. Even in that case, the orchestrator will declare that edge is down because it is not able to receive the heartbeats from the edge. And these can be a common scenario when you have a single link or an unreliable link like 4G or a broadband connection. Again, the important piece here is that the edge down and edge up alerts are management plane driven alerts. Fourth heartbeat missed from the edge to the orchestrator, that is the time where the orchestrator is going to declare that edge as down. It is triggered when the orchestrator is not able to communicate with the edge device. There might be a possibility when the edge device is able to talk to other edge sites or to the gateway. Maybe there is some communication issue between the gateway and the orchestrator. Even then, this edge alert is going to get triggered. So what are the things we need to check? Maybe edge device is not able to communicate to the gateway, or there could be a pairing issue, or there could be an issue completely with the gateway, or maybe the edge site is down, the edge has been powered down. So those are the things we need to consider when we are looking out for the edge down and up alert. To the next type of alert, which is the link alert. Again, in the link alert we have two different types. One is the link up and the other one is the link down alert. Now, the important distinction between the link alert and the edge alert: edge alerts are management driven alerts. These are those heartbeats which are sent every 30 seconds from the edge device to the orchestrator. And in case when the fourth heartbeat which is like in 1/22 is missed, we declare the edge device as down alerts. In the same heartbeat, we send out information related to the link stats. Link alerts are data plane driven alerts, and when I say data plane driven alert, it means the I'm talking about the VPN path. If you remember the basics, where when the edge device is zero touch provisioned, the moment the edge device is up and running, they will create and overlay the VPN tunnels from the edge device to the nearest gateway. They will create overlay tunnels. Now, if you have two WAN circuits, the edge device will create two WAN overlays from the edge device to the gateway. If you have four WAN circuits, edge device will create four overlay tunnels, the VPN tunnels from the edge device on those physical links to the gateways. So when we talk about VPN tunnels, we are talking about the data plane traffic, data plane alerts. So two consecutive alerts when they are missed. When I say two consecutive heartbeats which are missed, and that is the time when we trigger the link alert. Again, we are collecting the data plane information here. The data plane is the VPN overlay, those overlay tunnels which are built. So the minimum requirement for this alert to get triggered is that at least there should be one link or one connection for the VCO so that it can receive those heartbeats. So if your edge device has a single link, single internet connection, and if that connection goes down, then we are not going to trigger a link down alert. We will trigger a edge down alert because the heartbeat there is missed. But if you have two WAN circuits, if one of the WAN circuit goes down, we need the other WAN circuit to carry the heartbeat to the orchestrator. And if that heartbeat which is sent to the orchestrator, in that heartbeat, if it misses two consecutive heartbeats, in that we will declare that link as down. So if you have link 1 and link 2, and let's say for some reason the link 2 goes down, we still have the link 1 up and running, and that will carry the heartbeat from the edge device to the orchestrator. So in the second heartbeat, the orchestrator will declare link 2 as down, and that's where the link down alert will get triggered. And this is just a screenshot where the email was configured and the link alert went to one of the enterprise admin. So it's showing you the link down alert and the link up alert. Again, these have information related to the orchestrator link also. These are data plane driven alerts. Remember, the edge up and down are the management driven alert. Again, we need at least one connection for the VCO to receive those heartbeats. Now, how do we determine that if the link is up or down? Let's go back to the basics again. WAN links always create those overlays from the edge device to the gateway, from the edge device to the another edge device site, or edge device to the hub device. Now, if let's say on an edge device you have link 1 and link 2, now each link will create those overlays. Now, in any of these links going down, let's say link 2 goes down, and if link 2 has zero VPN paths, zero overlays, tunnels, then we declare that link as a link down alert. So if link 2 has VPN tunnel or VPN path equal to 1 or more, we will not declare that link as in down. And that is what is described in these two sections here. Again, because this is an important concept, I wanted to repeat this out. If we find link 2 has no VPN tunnels, we will indicate that link 2 is down. If the link 2 in that case has VPN tunnels equal to or more than 1, we will not declare that link as down. Let's say you have 5 VPN tunnels on that link and 4 of the VPN tunnels are down. We will not declare that link as down because the VPN tunnel count is still equal to 1. These tunnel counts are the overlays which are established from the edge device to the other endpoints. In this case, the other endpoints are the gateways or the other edge sites. And this is what is shown in this example here. Tunnel alert, VPN down alert. We have seen the edge alert, which was the management driven alert, the link alerts, which is the data plane driven alert. Now is the VPN tunnel down alert. Remember, this VPN tunnel down alert is for those non VeloCloud sites where from our gateways when we create those IPsec tunnels to those non VeloCloud sites. So these are only for route based VPN. These alerts are not for policy based. Now, again, the same concept of link alert applies here. From the gateway, we can have multiple IPsec tunnel to that single IPsec site. Now, if all the tunnels goes down, then only we are going to trigger the alert. If there is at least one VPN connection, one VPN IPsec connection from our gateway to that non-VeloCloud site, we are not going to trigger an alert. So that's an important concept here. So you can have 4 possible paths from our gateway to that non-VeloCloud site. So you have a non-VeloCloud site here, which is let's say you have a Cisco router in that site, which is configured with the IPsec, my edge device, which is on the branch site, and then the gateway, the VeloCloud gateway, which is in the cloud or on premise. So the IPsec tunnel get established from the gateway to that non-VeloCloud site. Now, if I have a single gateway, then I create a single IPsec tunnel. I might have primary gateway and secondary gateway. In that case, I'm going to create 2 IPsec tunnels from the gateway to non-VeloCloud site. So in this case, if one of the tunnel goes down and the other tunnel is still up and running, we are not going to trigger an VPN tunnel down alert. If both the tunnel goes down, that's the time this VPN tunnel down alert is going to get triggered. And these are some of the different configurations which are possible from the gateways to the non-VeloCloud side. So let's start from the bottom here. These are the different types. So you have a single IPsec tunnel from the gateway to that non-VeloCloud side. So in this case, if this single tunnel goes down, yes, we will generate a VPN tunnel down alert. Let's go to the second configuration here, where you have 2 IPsec devices on the non-VeloCloud side. So the gateway, a single gateway, has established 2 IPsec tunnels. So in this case, if one of the tunnel goes down, either one of the tunnel goes down, we are not going to trigger the VPN down alert. If both goes down, that's the time when we are going to trigger the VPN tunnel down alert. Now let's go to the last scenario where you have multiple gateways, gateway 1 and gateway 2, like primary gateway and the secondary gateway. They have established 2 tunnels from them to that non-VeloCloud site. Again, in this case, the tunnel count should be equal to 0. Then only the VPN tunnel down alert is going to get generated. Again, to remind you, this is a route based VPN alert. For policy based VPN, we are not going to trigger the alert. Again, this is a screenshot for the enterprise admin who got the email for the VPN tunnel down alert, which gives the information what tunnel is down, what was the name, what was the customer name, from which gateway the tunnel was created to that non-VeloCloud site, and the VCO link. Alert HA for the edge device on the branch side, where you have two edge devices which are in the high availability pair. So in this case, in the active standby mode, if the active edge device, any one of the interface goes down, that's where we are going to trigger this edge HA failover alert. Even if the dedicated link between the primary edge device and the secondary edge device goes down, we are going to initiate that trigger for the HA failover. This is just a screenshot of the HA failover alert, where it gives out the similar information what we saw in the edge alert and the link alert. This is what to check when the HA failover alert is triggered. Maybe the edge, which is the primary edge, has lost its power, or the services, or some of the services are down on the primary HA. This was the link I was talking about, which is a dedicated link between the uh, primary edge device and the secondary edge device. Now, who can get these alerts? What configuration we can do it on the orchestrator so that the enterprise admin can receive those alerts? So it's the customer admin and the operator admin which can receive those alerts for the edge side. For the orchestrator and the gateway, we need to have an operator access. This is showing you the screenshot where the alerts needs to be enabled at the customer level, and you can see here enable alerts. This is what needs to be checked. By default this is enabled, and once you go to the orchestrator under configure alerts and notification, this is where you can define those different type of alerts. If you remember, edge up and down, link up and down, VPN tunnel, which was from the gateway to the non-VeloCloud side, and the edge HA failover alert. On the right hand side you can see the notification delay. So let's say, if you remember, for the edge up and down, if we miss 4 consecutive heartbeats, we are going to generate that edge down alert. But that 4 consecutive heartbeat was 120 seconds, because each heartbeat is 30 seconds. So after 120 seconds, we'll wait for 3 more minutes before we declare that edge as down. This is what the notification delay is for. Similarly, for the link down, you can see it shows up as 3 minutes. Now, coming down, we can see we can configure the email addresses. We could also configure the phone numbers to receive the SMS. And these are the alerts which it will show when you click on the monitor section, monitor alerts, and this is where you will see all those alerts like edge up and down alert or link up and down alert. Events here. So we will log on to a live orchestrator, and we will go over the monitor event section. We'll also go over monitor edges, where we can monitor the branch site edges and the link stats. So let me quickly log on to one of the orchestrators here. So I'm going to log in as an enterprise admin to the orchestrator here. So let's log on. So the first time when you log on as an enterprise admin, under monitor edges, it's going to show you those branch sites. What's the status of that branch site, whether it is connected, offline, or it's an pending activation. It also give you a view of number of links which are connected to those sites. So you can see here, let's say for San Jose site, there are 2 links connected. For LAX site, there is 1 link connected, and it gives you an overview of what's the link conditions are. You can see for Chicago, one of the link is in degraded state. So it gives you a good map view, list view, and if you want to have more information, you can click on that particular edge device or the branch site, and you can get the link stats, the bandwidth usage, where it gives you the top application, the category for the application, and other details which are related to that branch site. At the same time, I can get information related to the latency, jitter, packet loss, which are the WAN impairments for the links which are connected to that edge site. You can see here the numbers changing because it's giving me the current stats. You can go from past 12 hours or from past 60 minutes to past 1 year. Then we also have a QoE, which is quality of experience, how good the links are working out for a particular application type. Let's say in this case, voice application. So I can go back and I can try out on the link condition. If any of the color codings here is yellow or red, that is the time when the link conditions are deteriorating, like a brownout condition or a blackout condition, and that's wherein we do the DMP, or the dynamic multipath optimization, kicks in, and either it steers the packets to a better link, or it will do some kind of link remediation in a dynamic fashion. The third tab we have is the transport tab, where we can also enter the live monitoring mode, and we can get details related to TCP or UDP level. So you can see here at this time, Time Warner cable link is seeing some TCP packets. Next, let's move on to the application. So here I can go back to past 7 days and I can find out what all applications this branch site have seen. So you can see here Office 365, it has seen around 1.28 gig, and you can see here that total of 62 plus 10, 72 application has been seen by this branch site in past 7 days. Remember, each branch edge device runs its own deep application recognition engine. Then we have the source and the destination, where in the source it tells me from which machine on the LAN side the traffic has been generated, what kind of a machine it was, what OS it was running, and other analytics related to that source. Destination and business priority, where you have marked those application as high, medium, low, and it will show you that how many bytes for high priority applications is seen in past 7 days. Similarly, for network services, where let's say for non-VeloCloud site, we can get the details on what is the non-VeloCloud site status here is. It will also give you other details like the if the BGP is configured. So here you can see for Dallas branch site, the BGP is not in established state. For let's say San Jose site, the BGP is in established state, and it will show me what all prefixes it has learned from that site, how many prefixes it has learned. So these are some of the details it gives out over here. Next is the monitor event section. This is where you get a consolidated view of all the events. I can also do a sort here. So let's say give me all the information related to the Chicago site, and you can see here it gives me all the information related to the Chicago site. I can go from past 7 days to past 30 days, or from past 60 minutes to past 12 months for the events. Similarly, we can configure the SNMP monitoring on the edges, or at the edge level, or at the profile level. We support both SNMP version 2 and version 3. With version 3 you can collect more information, and these are some of the MIBs which are supported by the SNMP. NetFlow's standard NetFlow configuration, API monitoring. You can use the orchestrator to collect and forward the API information to a third party tool. So let's say a service provider or an enterprise customer is using a third party monitoring tool, so we can pull out the information from the orchestrator and feed that information to that third party monitoring tool. I mean, that's just one of the use cases. The other use cases are for monitoring and provisioning. You can use the API to provision a site or a link or other things. These are some of the examples related to the API monitoring. Troubleshooting tools. These are some of the troubleshooting tools which are available in the orchestrator. Remember, there is zero CLI for from the orchestrator, so we can use the orchestrator monitor tool where it gives you the map view, the list view, it gives you the analytics related to the orchestrator, sorry, for the edges, monitor edges. It gives you the consolidated view, it gives you all the analytics related in a single page, and if you want details you can select one of the edge site and it will give out the information related to that branch site. It gives you both the historical and the real time data. If you remember, I can go to the monitor edges and I can select the Chicago site, and here it will show me the current stats. So it's giving me an historical view. If I go back, let's say past 30 days or 6 months, at the same time it is showing me what activity is happening on this particular link. As you can see, the numbers are getting changed here. The next one is packet capture. You can also do a packet capture. You can do remote diagnostics for the edge device or even for the gateway, depending on the privilege level. Diagnostic bundle, where all the log files for that edge site are captured and you can download it to your machine for further diagnostics. So let's quickly go over the orchestrator, and you can see here the test and troubleshooting section here. So let me start off first with the remote diagnostic. So here, when we click on the remote diagnostic, it's going to enter, or it's going to log on to that Chicago site remotely from the orchestrator, so you don't need a remote admin at that Chicago branch site. And these are some of the tools which you can use from the orchestrator. So let's say I can do list path, and I can select the gateway and I can select run, and it will show me all the overlays which are built from the Chicago edge device on those physical WAN links to the gateway. So you can see here on the Time Warner link, it has built up two overlay tunnels to the gateway. So I have primary gateway and secondary gateway, and to these two gateways on from a single link we have built up an overlay. At the same time, I can do ping, trace route, I can do a show IP route, which is the route table dump, and I can get that information just for the Chicago site. Let's wait for the output to come out here, and it will show me all the routes, possible routes this edge device, this Chicago site can reach for a particular subnet. After remote diagnostic is the remote action. So for remote actions, I can log on to the Chicago site, I can reboot that site, I can identify if in that remote site if there are multiple edge devices. I can click on identify and it will start blinking the front LED of that physical edge device just to identify that this is the right edge device. Restart services, reboot, shutdown. I can also do an deactivation. Like I mentioned, we can also do a packet capture from the orchestrator. So I can request a PCAP bundle, let's say for Chicago site here. Duration I can select, and I can select link down as the reason for generation, because Chicago has two internet connections two WAN circuits and one of the link is down, and we can collect that information on an interface basis also. So I can click on submit. You can see here I don't have to call a remote admin to do the packet capture or the remote diagnostic for me and send it over the email. And because of the file size, maybe they are not able to send out the email with the attachment. So as an admin from the orchestrator, I can do the packet capture and I can download that image to my local machine for further view. So let's go back to our presentation here. So it just shows you at what level, user level, you will have access to these tools. I think we have already gone through these QoE score, monitor events, monitor edges. So I'm quickly going to go over these tools here. So you can see here we talked about remote diagnostics. We have seen what tools are available from the remote diagnostic. We gone through the list edge path and other parameters here. Remember there are zero CLIs for the VeloCloud orchestrator. All the troubleshooting, monitoring, we do it from a single place, which is the orchestrator. So I can quickly. So once you download the diagnostic bundle, you will see the log files, and you can open one of the log files, and you can view the what exactly there might be the issue there. So packet capture, it just shows you the screenshots here. So I'm going to move on to the common issues. What are the common issues we generally face? So customer calls and tells that, hey, I cannot reach a particular destination, or I still have a poor application performance. These are some of the very frequent issues. So we can talk about one of the issues here, that I cannot reach a destination next. So what exactly do we need to check? Do we have uh, path to the gateway? Can we determine the source and the destination IP for that flow? What's the destination IP in there? We should go to the list path in the remote diagnostic, and we should check out for the route. We can do the dump of the flow. We can also check out the routing table and find out whether we are able to reach that destination. VPN status, again we can find out from monitor network services section 2 what kind of routes are there. Business policy config, maybe the application is not configured to go over the overlay, and that's why customer is seeing poor application performance even after implementing the SD-WAN solution. Deep packet inspection. Remember that the edge device is a smart device. It doesn't only do the routing functionality, it has the firewall functionality. It has inbuilt software which does the deep application recognition engine. Like today we can recognize more than 2800 plus different applications. So this shows you the flow of when the application traffic hits from the LAN side to the edge device. What exactly do? We also not only check for the static database for the signatures, but we dynamically learn it, we cache it, and next time we don't pass on the flow to the deep packet inspection engine. From the cache flow we can recognize that, oh, I have identified this flow, and then we can pass it on to the next level. If for some reason the flow is not identified, or during the three-way handshake, or just after the three-way handshake, when the flow is not identified, during that time we use the default flows. We just talked about the application performance, what all we need to tools we need to leverage to check out for the poor application performance. I think a good way to start would be go to the quality of experience scorecard from the orchestrator to check what time or what time interval we are seeing that issue, whether that application is going over the overlay tunnels or it is going underlay. So that we need to check it from the business policy. So it's always good to check out the business policy for a particular application to see whether it is going overlay or underlay. If it is going underlay, then we need to look into the policy and change the policy so that the application can go over the overlay tunnels and we can apply our DMPO, which is the dynamic multipath optimization, to that application. This is just an example of what minimum data sets or what information we should collect, and this is what is shown when you call a support. So the key takeaway from this session was that to identify different type of alerts, we went over the six default alert: edge alert, the link alert, the VPN, HA failover alert. What differentiate them? We have a 30-second heartbeat which is sent from the edge device to the orchestrator through the gateway. Edge alerts are the management driven alerts. Link type alerts are the data plane alerts. When I say data plane, it is all about the VPN overlay. The third alert was of the VPN tunnel down alert. This is the alert for those IPsec tunnels which is established from the gateway all the way to the non-VeloCloud site. After the alerts, we went into the section of events where we know how to get information about a particular branch site, whether it is connected, what's the status of that branch site, how many links are connected to it, what are the status of those links. We also constantly monitor the WAN impairments on any links, and there is a quality of experience score for any application like video, voice, transactional applications. We maintain a quality scorecard which you can view it in the current, you can get a current view or you can get an historical view where you can go from past 60 minutes to 1 year. We also have a monitor event section where you get a consolidated view of all the events. Then we have those tools which you can use to do the troubleshooting. So tools like show IP route, list path, VPN status, ping, trace route. You don't have to do any of these from the CLI. There is zero CLI involved. All the simplicity, all the tools are built into the orchestrator. Thank you.